All right, let's dive into one of the biggest, most mind-expanding ideas in all of science, the multiverse. It's a concept that really pushes the boundaries of what we think of as reality. So, let's get right into it.
So let me just start by throwing a question at you. Are there other versions of you out there? Like right now? Infinite copies, living in parallel universes, where every single one of them made a different choice than you did. One of them had the oatmeal this morning instead of the toast. Another one took that other job offer. Maybe one never even met your partner.
I know what you're thinking. This sounds like it's been pulled straight from a comic book or a sci-fi movie. And you know what? You're not wrong. But this exact idea also pops up from our deepest, most fundamental theories of physics, and it's being seriously debated by some of the smartest people on the planet right now. So let's find out why this is so much more than just a cool story.
Our journey into the multiverse, funnily enough, doesn't actually start by looking out into other worlds. Nope, it starts by looking right here at a really deep and nagging puzzle about our own universe.
So here's the puzzle. The fundamental constants of nature, things like the strength of gravity or the mass of an electron, the amount of energy in empty space, they all seem to be set to these unbelievably precise values. If you were to just nudge any of them by the tiniest fraction, the universe as we know it would just fall apart. No stars, no planets, no chemistry, and definitely no us. It really is as if the universe was perfectly, and I mean perfectly, dialed in for life to exist.
To give you a sense of the odds here, take a look at this number. That's the probability of being dealt a royal flush in a 5-card poker hand. It's incredibly rare, right? Well, the odds of our universe having these life-permitting constants are, by a lot of calculations, so much smaller it's not even funny. We're not just talking about winning the lottery. We're talking about winning every single lottery every single day for 1 billion years.
And that brings us to the real kicker. If there's only one universe, if the cosmos got just one shot, one single deal of the cards to set its physical laws, then our existence is a statistical miracle of the highest possible order. To put it simply, we are just unbelievably, staggeringly lucky. And for a lot of scientists, just saying we're lucky doesn't really feel like a good enough scientific explanation. So if we're not just incredibly lucky, what's the alternative? I mean, how do you beat impossible odds? Well, one way is to get more chances, a lot more chances. And that, right there, is where the multiverse enters the picture.
The multiverse hypothesis offers a pretty elegant solution to this whole fine-tuning problem. The idea is really simple. If you deal enough poker hands, eventually a royal flush is going to show up. It's not a miracle anymore, it's just a statistical certainty. So in the same way, if there are a huge, maybe infinite number of universes, and each one gets a different roll of the dice for its physical constants, then it's really no surprise at all that at least one of them, the one we happen to be in, would have the perfect combination for life. We exist simply because we're in one of the universes where we could exist.
Now here's where things get really interesting. The word multiverse isn't just one single idea. Physicists have actually come up with several different ways a multiverse could exist. The cosmologist Max Tegmark came up with this really useful framework that sorts them into 4 distinct levels.
Okay, let's try to break this down. First up, you've got level 1. This is the simplest one. Our universe is just infinite, and there are other patches of space way out there just so far away we can never see them. They'd have the same laws of physics we do. Then you've got level 2, which comes from a theory called eternal inflation. This one suggests our universe is just one bubble in a giant cosmic foam, and each bubble could have different physical constants. So that one really speaks to the fine-tuning problem. Then things get really weird with level 3, the many worlds of quantum mechanics. This is the idea that every time a quantum measurement is made, the universe splits, and all possible outcomes happen, just in separate branches. That's where those infinite copies of you come from. And finally, level 4. The most mind-bending of all. It basically says that any mathematically possible universe actually exists, for real, somewhere, each with totally different laws of physics. Right about now, you're probably asking a very good question. If we can never see or visit these other universes, how in the world can this be considered science? And that is the central debate. It all boils down to one big idea: falsifiability. So, we all have this sort of simple bumper sticker idea of how science works, right? The philosopher Karl Popper made it famous. A theory has to be testable. You have to be able to imagine an experiment that could prove it wrong. So critics of the multiverse say, hey, we can't observe other universes, so the theory isn't falsifiable. So it isn't science. End of story. But a lot of scientists, like physicist Sean Carroll, argue that's way too simple. They say that a theory's value also comes from its power to explain things we can see, like the perfect fine-tuning of our own universe.
And Sean Carroll just nails this argument with this quote. He's basically saying that this simple falsifiability test was never the one and only rule for what counts as science. It's more complicated. Theories like the multiverse are on the table because they seem to be the logical outcome of our other really well-tested theories, like cosmic inflation and string theory. And, again, they offer an explanation for real data we've actually observed.
But I have to be super clear here. None of this is settled science. Not even close. The multiverse is on the absolute cutting edge of theoretical physics. And even among the experts, there's a huge, fascinating debate happening right now.
This chart really tells the whole story. It's from a recent survey of physicists on the early universe. And as you can see, cosmic inflation, that's the theory that often leads to a multiverse. Yeah, it's the frontrunner, but it only has 44% of the vote. That is a long way from a consensus. It just shows you that this debate is completely wide open.
And the debates? Oh, they get so much weirder. One of the biggest problems for a lot of multiverse models is this bizarre and frankly kind of terrifying idea called the Boltzmann brain. The idea is that in a huge multiverse that lasts for an almost infinite amount of time, random particles could, just by pure chance, assemble themselves into a fully formed conscious brain. A brain that has completely false memories of a life it never lived before it just flickers out of existence.
So here's the kicker. Statistically, it is way, way easier for random chance to just pop a single brain into existence than it is to build an entire complex, orderly universe with billions of years of history and billions of brains like us. So if these multiverse theories are right, it's overwhelmingly more likely that you are a Boltzmann brain with fake memories than a real person in a real universe. And since we generally trust our senses and believe we're real, well, that suggests there's something seriously wrong with any theory that leads to such a wild conclusion.
So you see, the multiverse doesn't just challenge our scientific models. It forces us to wrestle with the absolute deepest philosophical questions we can possibly ask. Questions about where everything came from, about creation, and about the nature of reality itself.
For centuries, philosophers have used arguments like this one, the Kalam cosmological argument, to make the case for a first cause, something that started everything. For a while, the Big Bang looked like it could be that beginning. But the multiverse, well, it really complicates things.
You see, if our universe was just born from some mother universe in a multiverse, you haven't really answered the origin question at all. You've just pushed it back a step. So where did the mother universe come from? And if you say it's just an infinite chain of universes birthing other universes forever, you hit this weird logical wall called a bootstrap paradox. It's like a time traveler, going back in time and giving Beethoven the sheet music for his own Fifth Symphony before Beethoven ever wrote it. So, who actually wrote the music? In that infinite chain, the information that defines our universe has no ultimate creator. It just is.
And that's really where we have to leave it. The multiverse gives us this compelling, scientific-ish reason for why our universe seems so perfectly made for us. But it also leads to these bizarre paradoxes, deep philosophical problems, and that unsettling idea of infinite copies of you out there. So the question is this: is the multiverse the final answer, the ultimate explanation for our place in the cosmos? Or is it just the beginning of a whole new set of even bigger, even more profound questions?